Am I audible? Hello. Good evening. SEO. How are you, people? Good. There's noise. Everyone listens some noise, or it's clear? Clear, na? Fine. ठीक है. So what I'll do now, first of all, let me go here. Just a second. Just give me a moment. I'm connecting something here. Everyone can see my screen of OneNote. Okay. ठीक है. Okay. So, guys, today's agenda is to solve some more problem, which will be totally oriented to the recursion. Okay. Okay. And if you can able to solve this kind of problems, trust me, you will be able to solve any kind of problem with respect to recursion. Okay. Let me just first create for today's file. I have already uploaded this. I hope everyone got this. So this will be recursion problem solving part 2. Okay. In the previous session, we are supposed to solve some more problems, but we actually eventually I was into some another problem, right? Because the binary problem that we have solved, that was not in DAC, but we had solved that. Okay. Okay. So you remember the binary problem that we did? The count of the binary problem, right? Every one should not be the consecutive one. That problem. Everyone remembers that? Yes or no, guys? Yes or no, people? Sequence, no, not the sequence one what was in the DAG. Okay, subsequence ones was in the DAG, but the binary problem that we did, that was not in the DAG. But we had solved the Fibonacci series before, right? So that problem was in my mind, so I eventually told you to like I eventually explained that problem also. Okay, but in the previous session we were supposed to solve some more problems that we will be covering today also. Okay. Okay. In the previous session, as we have remember, we have solved Fibonacci series. The second one, we have solved the binary problem. The third one, we have solved the sequence problem and some minor problem in between also, right? I'm not recalling the exact problem that we did, right? So this was all and all the basic overview of the session of the of the previous session, right? Okay. Okay, so in today's session we will be solving some more problems. I trust me, you will be in love with this. Okay, you will be in love with this because this is like very easy problem as compared to, like, if I tell you to do, this will be like very easy problem to do, and this will not take a lot of time of yours also. If you understand the problem, if you understand the solution, then it would be, trust me, it would be the piece of cake for you while you are coding. Like, आपने अभी भी ऑब्जर्व किया होगा ना, like understanding the problem, like cracking the problem is the main, what we can say, like the heart and soul of the problem, right? Coding is not the problem for us, for your batch particularly, because you guys can code, you just want to understand the concept. Yes or no? I feel everyone will agree with me with this particular batch. So for those people who are actively responding to me, for those people who are very active in the batch, they know that how to code, but they just want that how to crack this problem, है ना? They just want the logic. ठीक है? Right? Yes or no? ठीक है? Okay. So overall, we will be focusing today of logic. Okay, some of the problem I will explain today, I'll tell you the logic, or we will discuss the logic together, but we will not code the entire thing. We will code it as and when required, but I will give you some time to code also. Is that making sense? Okay, fine. So from today you will observe this kind of one change in our session. Okay, so surely, like, no, gradually we will be moving towards the tougher part of the problems. That is what expected. Okay, that is what is expected from the today's session. Fine. Okay. Okay, so Parag says that I am little bad in code but good in logic. That's great. That's great, Parag. If that is your strength, like your strength is what? Your strength is to think about the logic. That is the main strength. Okay, anyone can code, but not everyone can think the logic. Okay, so don't worry about it. Okay, so from subsequent question, I didn't understand. Okay, fine. So Vaibhav, this syntax is what something called as, if you want to copy some array, like this array is having 5 elements, let's say. Okay, so you want to assign this particular array to something else, like array 1. Okay, so if you write this particular thing, it will assign everything to this. Okay, this is particularly known as, like, there are two name of it, like spread and rest operator. This name is spread operator and rest operator as well. What is difference between both of them, what is that actually called, I will probably cover in today's class if time permits, or else in the next class, or in the doubt class you can ask me about this. Okay, I think we have not covered in the class this, so probably we will not cover in the doubt class, we will cover in the regular class. Okay, so for now, if you want to understand, like, this was not in deck, so that's why I didn't explain you this. But if you just want to understand, this is the thing by which you can assign entire array to something else. For now, just think about this. Okay, once I'll explain about this rest and spread, you will be much more clear about it. Okay, okay, fine. So now our first problem for today is, like, apart from this subsequence, like every subsequence problem, what is the logic of that, that is clear with you, right, Weber? Apart from this one, है ना? So that's great. ठीक है, no worries. So now our first question is for today is the simple one. I'll make it very simple, but you guys have to support me with in this particular thing. Okay. So our first question for today is to print a parenthesis. Okay. So it's like very lengthy question when you can think about it, but when we actually code it, it will be like very easy one. Okay. Okay. So what this particularly parenthesis problem is, I will give you a number. Okay. So you have to generate the parenthesis. I'll give you a number. Let's say I'll give you count of parenthesis. I'll give you this. Let's say I'll give you two. Okay. For an example. So how many combination you can generate out of this two number when you are thinking about the parenthesis? So parenthesis is nothing but this. This is called a parenthesis. Okay. So if I can tell you that you are having two parentheses, you have count of two parentheses, that does mean that this is my first parenthesis, this is my second one, right? This is one way to write it. Okay. Another way to write it was this one and this one. Apart from this two, there is no way you can write it. Okay. Okay, none of the parentheses would start from this. Okay, parenthesis would always start from the opening parenthesis. Everyone agrees with me this particular this part? Okay. Okay, so this is our problem is. So for an example, suppose if I'll tell you that hey sir, my n is now 3, instead of 2 my n would be now 3. So you have to generate this parenthesis for me. So what I'll do, if you have three parentheses, so first of all, this is my first, second, third. This is my first way to write it, right? Second way would be what? Like two opening parentheses, sorry, three opening parentheses and three closing parentheses, like this. Okay, okay. This one also I can do. I can also do one opening parenthesis, one entire parenthesis, and what is remaining after this, it's like the single one. Okay, fine. This is third way to write it. Another way I can write it is what? I can write it like what else I can write it like write with this. I can write like single parenthesis, like totally mirror image of this. Okay, so like this. I can also write this like, right. Apart from this, I can also write this like one parenthesis, second, and this is my third. So this is the only thing which I can implement from n equals to 3. Yes or no? So if you observe how I was writing the parenthesis, you have some hint about it, how to implement it. Question is clear? What you want to, like, whatever, like what you want to print in the console? ठीक है, you will be having a n, you have to generate every possible solutions with the parenthesis, right? So just to give you a hint, just to give you a hint, if you have understood this, so if you have observed, if you have observed, so how many ways to arrange them? Yes. Okay, yes, it was somewhat similar to that, but not exact one. So I'll give you some hint about it, then after I'll give you some time to think about it. Okay, so if you have clearly observed here what we did, like there are some pointers to take care of here. Okay, so whenever I was writing the parenthesis, so let's say, I'll write this. Okay, so you'll remember. So let's say, uh, if we are said, and trust me guys, these problems are very much important. Okay, if you go to any platform of coding, these problems would be there. Trust me, these problems would be there for sure. Okay, this will be marked as like not easy one, this will be marked as intermediate ones. Okay, so if you understood this, you are on right path. Okay, so just try to understand this, what I'm telling about this. Okay, so if we are said that we need to print all possible, suppose we need to print, I'm writing this so that you can refer this later on. Okay, you have to print all possible valid parentheses. Let's say n equals to 3 for example. Parenthesis. Suppose I will take n is equals to 3. Okay. So for this, what we did. Okay. So ideally, we will have which how many number of solution? This was my first solution, second one, third one, fourth one, fifth one. Right? Okay. Right? Yes or no? Anna? This was the only solution that we can think about it. Right? Okay. ठीक है ना? Okay. So now, when we have n equals to 3, okay, when we have n equals to 3, so our first point would be here to notice, uh see, number of opening brackets should always be number of closing brackets. Okay, so if you see here, every solution, number of opening brackets, like this will be always equals to this, like closing brackets. Okay, in every solution. So my first observation is number of opening brackets should be equals to closing one. Okay. My second observation that I can take from this is my closing brackets cannot come before opening bracket. Okay. This is but obvious, right? I also told you here, the closing bracket would never come before opening bracket. Okay. This is my second observation. Closing bracket never comes before opening one. Okay. My third observation is like total number of count of opening bracket cannot be more than n. Yes or no? Right? So like I'll write it like this, like total number of opening brackets can't be more than n. Okay. Okay, so these are my only observations that I can observe, like that I can implement from this, right? Okay. Yes or no? Enough, right? So anything apart from this particular uh, five thing that you can think about, any particular thing? No, right? Yes or no? So see, forget about this right now. If you have this particular observations, and I'll say you have n equals to 2. Okay, you have n equals to 2. So so total number of, like third one nishant is total number of opening brackets can't be more than n. Let's say if you take any particular solution from this, okay, so in that everything your opening brackets is always 3 है ना, it cannot be less than or greater than 3. Yes or no? Every solution would be having, sorry, it yeah, every solution would be having at least 3 opening brackets है ना, so it will be not exceeding more than n. This is what is said. ठीक है? So in this particular thing, you have to tell me first of all the base condition. What will be our stopping criteria? Yeah, it's also same for the closing. Okay. Okay. I'm giving you some time. Please think about it. Please think about it and let me know what you can think about. Think like what your suggestion would be on this. Okay. Fine. Okay. So once you are ready with your base condition, try to make a recursive call. Okay. The second step. Fine. I'm giving you some time, not code. I just want some logic, some dedicated logic for this that it's acceptable. Okay. Ripanshu, how can you count a pair? Because we have only n. This is only our input, right? From this we have to generate this. This is our input. From this we have to generate this, right? Okay. So you have to think a solution which will be work for entire whatever number I will pass. It should generate a possible number of solution, and we have to print this everything. Okay, I need to print this and this for n equals to 2. Fine. Okay. So I'm giving you some time. Please think about it and let me know what is your observation from this. Okay, that would be fine. Making sense? Okay, ठीक है. चलो एक और हिंट दे दूं मैं आपको. हाँ. Okay, so please see in the board. Okay, please see carefully in the board. I'll give you some, like I will tell you something, maybe you will have a click on by this. Everybody is here. Everybody, for some time please see in the board. Please see on the board, I'm giving you some hint from this. Okay, so let's say you have to print what number of valid what permutations, or we can say number of valid parentheses. Okay, fine. So suppose if I'll take my n is equals to 3, fine. So I told you that every time my solution would be start from this. Okay, okay. So I'll first of all I consider this. Okay, empty parenthesis. At this particular time, at this particular point of time, my open count would be always 1 and my close would be always 0, because I have to start from this now opening bracket only. So I'll mark my close count as 0, open count as 1. Okay, okay. After this, I'll one more open this. Okay, I will open this once more. Okay. At this particular point of time, my OP, that will be my open. OP will be 2 and close would be 0. Okay. I'll again go further. My n is equals to 3. Please note. Okay. At this particular point of time, my OP is equals to 3, CL is equals to 0. Okay. Okay. This is the only thing that you can think about it, right? है ना? Now after this, you have observed that my OP is now equals to n, है ना? So whenever your OP is equals to n, you cannot open one more. Okay, if I do this, this is not right, right? I have to close that only. है ना? This is the only option that I can have right now, right? So what I'll do after this, I'll close one. Okay, okay, I'll close one. So at this particular point of time, my OP is what? 3, CL is what? 1. Okay, I'll close my counter till the time my CL is equals to OP, because my opening brackets are 3, right? So I have to close 3 also, right? Okay. So at after this particular point of time, I did not have any option, so I close that. So I have to close it till the point of time my CL would be equals to OP. Okay, so I'll close one more. I'll close one more. Okay, right? And if you observe, if you have observed, every time, every time your solution will become like, every time if you have 2 into n, है ना? Yeah, right now if you see, right now my n is equals to 3, right? So if you have 6 characters in your string, your answer is done. Okay, see, in every solution this will be always length of 3. This will be always length of 3. So can I say that anytime if I have my answers character is 3, my answer is done? I need to print it out, right? So after this particular point of time, what I'll do, I have to check the count of the length of what I have just got from the previous one, right? So after this, now here we are emphasizing on opening only, right? So we have to backtrack. Okay, so after this, what I'll do, I'll just check my length of the string, whether it's equals to 2 into n. Yes, it is. So I need to print this out. So I will print this one. So this is my first one. Okay, right? Okay, this is my first possible solution that I can think of, है ना? Now, what I will do after this point of time, I close my last bracket. I do not have any other option. I cannot open also, I cannot close also, because at this particular point of time, my OP was 3, CL was 2. At this particular point of time, my OP is 3, CL is 3. So whenever your OP is equals to n and CL is also equals to n or equals to OP, you need to backtrack. Backtrack, that does mean that you have to you have to do one more back operation, है ना? You do not have to go further, because you do not have any choice to go further, because your every task is done, है ना? ठीक है? So when you backtrack, see, at this particular point of time your OP is 3, right? Your OP is 3, so you cannot do anything. At this particular point of time also, you backtrack from here also. Like, first of all, I backtrack from here. I check my OP is 3 equals to n, so I cannot do anything. I will go here. My OP is 3, I cannot do anything, because right now we are focusing on opening brackets only. Okay, please note that. Okay, my OP is 3, so I will go one back. Here also my OP is 3, I'll go here. So here I can do something, because my OP is 2. Okay, so this position, this is a position where I can do something. Okay, so at this particular position, what I will do, okay, my OP is 2 right now, so I will, what I'll do, I'll close one. ठीक है, one time I have opened one time I will close. ठीक है, एक time मैंने open किया, एक time मैं close करूंगा. So at this particular point of time, what my OP is 2, CL is 1. ठीक है, okay. So now what I'll do after this is I'll check my OP is 3 or not. So here, like when we backtrack it, we went to OP equals to 2 because in every other case my OP was 3, right? So in every other case my OP was 3. Agree with me or not? Okay. So for that reason I backtrack every solution and I reach back to OP equals to 2. You know? So now I have to close one, right? So OP equals to 2 and CL equals to 1 now. And for this, like till this point clear? Till this point clear, people? Yes, no? है ना? So why we backtrack it? And when we reach the solution where OP was not equal to 3, this particular point of time, when I just have to open that, right? At one point of time I close that, one point of time I have to open that. Okay. Now after this particular solution, after this particular getting this solution, what I can do? Either I can open, either I can close, right? So what I'll do after this particular operation, I will open one. Okay. So now at this particular point of time, OP is equal to 3, CL equals to 1, right? Okay. So now once I have my OP equals to 3, I need to close every bracket till my CL equals to not OP, right? CL has to be equals to OP after OP reaches to N, right? So I need to close every brackets. I got this. Now I'll close one. So now it will become this. I have to close another one because I cannot open after this, right? So this will be my second solution. Why? Because my total number of lengths are what? 2 into n now. है ना? So I need to print this both of them. This will be my second solution. Cool. ठीक है? Okay. Now, ठीक है? So now what I'll do, I'll make one new tree. Since I got this particular two solutions, I did not have any other option here. So it's like, uh, see what I'll do, what I'll explain from this is like, since we got the two solutions, right? So since this, I'll explain once again for those who did not, who have some doubt in this also. So see, after this particular thing, uh, when I have this, okay, after this, okay, when I had this like this from here, okay. So after this, what I'll do, we are focusing on opening, okay, we are just focusing on opening right now. So we will open the bracket, and since OP reaches to 3, we will mark CL equals to 3 as well. Okay, we have to mark CL equals to 3 once OP reaches to 3. So we close every bracket from there and till it reaches to CL equals to 3, right? So we, after particular this point, till my OP equals to 3, CL equals to 1, I do not have anything to do because I cannot open any anymore, right? So I have to close one. So I have to close till the point of time it will reach to 3. Okay, so I did the same and then I got the second solution. Okay. Okay. Since like this is my 2 into n case, I'll also print this. Okay, since it will be followed my 2 into n case, I'll also print this. Cool. Okay. Now here we have another option to close. Okay. Okay, previously we taken for open, now we will close after this. Okay, after this we will close. Okay, here if you observe, after this we have opened, after this we will close now. Okay, we'll consider that case. So if we had this, right, so we had this. Now what I will do, one time I'll open, right, है ना? So yeah, sorry, one minute. I have to explain from this only because you will not get that because I have to traverse every tree again and again, right? So I am supposing that you got this particular point. I'll just if I delete this, I'm not sure you will get this or not. Let me take some another pen so that while you are revising the things, you will get to know this. Okay, yeah, this one. So now after this, see, one time we open one. Now after this, like we opened one. After this, consider this particular part, right? Okay. So after this particular point of time, one time we opened, one time I'll close like this. Okay. Okay. So now at this particular point of time, what my OP is 2, CL is also 2. Yes or no? Okay. Right. Now after this particular point of time, I have an option of open. Okay. If I open, I have this. If I open one, my OP will be 3, CL will be 2. Now, since my OP is 3, I have to close everything from this. Okay, that is the rule of thumb or the common sense. Okay, because once you reach to the opening bracket 3, you cannot open anything. You just have to close one till the point of time it will reach to 3. Okay, so this will be also followed my what 2 into n fashion, है ना? This is also followed my 2 into n fashion. So this is my third solution, right? ठीक है, pretty easy, है ना? Okay, ठीक है. So now this was my third solution. Okay, so now I do not have any space, so I'll write another tree for this. So since we have covered all the options with two brackets, right, है ना? Till now we have covered all the options with the two brackets. Okay, so we have to return back to this single bracket, and it will have now one open and one close. Okay, so if you observe here, if you have observed here, after particular this we had open one, so now we will close it, है ना? ठीक है, this is the only thing that we can do, right? So I'll write this. Previously we had opened one. If you have, if you see here, we have opened one bracket right after this. Now I will close this. Okay, so now I'll do this. Fine. Okay, okay. After this particular point of time, since my OP is 1, CL is also 1. Okay, after this particular point of time, I'll open, because I'll always have that particular thing in mind. Whenever my OP will reach 3, I need to close it, and I have to make my CL is also equals to 3, right? Okay, so now after I have to do this, I'll open 1. Okay, now my OP will be 2, CL will be 1. Fine. Okay, after this particular point of time, I will open one more. Okay, I'll open one more bracket, and I'll open one more bracket. Okay, and my OP will be now 3, CL will be now 1. Okay, okay. Whenever you have any choice, you have to open it. Okay, if you can open, like here I have one option of opening, one option of closing, right? So I always choose opening one. Okay, because I have thing in mind that I need to make my OP equal to 3, because after this I need to close every brackets. Okay, this is what in my mind. Okay, okay. So once I reach my OP equals to 3, CL equals to 1. Since my OP is equals to 3, I need to close now, right? One close. So my OP is equals to 3, CL equals to 2, and the final one. Okay, this will be what? OP equals to 3, CL equals to 3. This will be followed by what? 2 into n option, right? So this is also my one of my solutions, right? Now the final thing that I can do here, the final thing that I can follow here is, see, the final thing that that I can do here is, see, after this one time we opened this, right? One time we opened this, one time we closed this. So everything of every options of this are covered, right? Okay. Now just we are left with the option of this. Okay. So one time we have opened this. Okay. One time we have to close it. है So after this particular thing, what I'll do, I'll mark some another pen. Okay, fine. So one time I have opened this, one time I will close it, right? I'll follow this, uh, this one, and now I have to close it. Okay. So now at this particular point of time, my OP equals to 2, CL is also equals to 2. Now I have option of open also and close also. I'll always follow the open one. So I just a second, I mistakenly write it something else. I'll open one. Okay. Now once I reach my OP equals to 3, C equals to 2. Once I reach 3, I need to close everything. Okay. So this is what my solution 3. Okay. So this is all that you can do from this. Okay. Apart from this, you cannot print anything. Okay. There is no option left. Okay. So this is what our main logic is. And if you have observed our base case, then our base case was always what we were checking every time whether our solution's length is 2 into n or not. If it is, then we have to print it out, okay, and return from that. This is what our solution is. And after that, after this, we have to backtrack, है ना? Yes or no? Why not CL first tree? What do you mean by that, Suroj? Please come online, because in this I cannot no get through it, like what you exactly mean to say, because we have 3 or 4 trees, right? So in which tree you are telling me, I do not understand that. Please raise your hand. Clear? Okay, fine, great. So guys, you are clear. At any point of our can't be greater than close. Yes, it cannot be. Okay, at any point of time, our open bracket cannot be greater than the close bracket. Okay. Yes, we have only choice to open. That is also you can tell. Okay. So base case is clear for everyone. What is our base case? Okay. What is our base case is clear. How do you like? How can you make a recursive call? That is also clear with you. And just the thing that I need to teach you here is to backtrack. Okay. So if you see here, we backtrack it. है ना? For every solution till the time our opening bracket was not equals to n. है ना? Right? This was the heart of the solution. Right? Okay. So if you want to backtrack, then you use something called as pop. Okay. So first of all, we have a result, like we will have an array. So if I tell you the algorithm, you want me to tell you algorithm, like I just have to give you a hint, but eventually I explained every like entire problem. You know, I just took my pen to give you a hint, but I explained the entire problem. You want me to give you some hint about algorithm? Okay. So see what we can do in algorithm is, so first of all I'll have my base case. Okay, I'll have my base case. So in base case you are clear. Whenever, so that, see, whenever we are calling our main function now, let's say, let me delete this. Let's say my, if I'll name my function of like print parenthesis. Okay, print parenthesis. Inside this, whatever my input would be, this is what called a signature. Okay. Whenever you are making out on paper, like we are declaring right now, what will be your function, what will be your input parameter, this is what something called a signature, and this is what it will become in your analysis part. If as and when you will move to no upwards in your career path, you are supposed to analysis, you are supposed to make analysis, a strong analysis you have to make. Okay, in that particular point of time you have to gather your requirement, and you have to no matter we are working in service based or product based, that's not an issue. In that, every time in whichever product you are working, in whichever project you are working, in that particular product, you have to make this particular thing. This is what something called a signature. So in if I'll make a analysis of this, then whatever my signature will this, and inside this is, I'll make a result variable, or else my array, this will be my array, in which I will print everything. Okay, this is my result parameter, result array, and another parameter will be my open one, my open count like op. Next will be my close, will be my cl that we have used in the solution, and the last one will be my n, whatever n I will pass. This four will be my input parameter of this particular function. Inside this function, I'll do everything, and I'll call repeatedly this call. Okay, so I'll declare my base case from here, I'll recursively call from here, and I'll return after this. This is will be the same whatever we looked upon in the previous scenarios. Okay, so this is something called as my signature. This you have to do, like, pardon my writing, because I am not in a position to write in a better way because my hand is hurting right now. Fine. So this will be something called as what the analysis part, right? Signature part. Inside this, I need to make everything. So first of all, whatever my base case, I'll write it. So what will be your base case here? Your base case here is simple. Whenever your result dot length, we check this every time. Now we will input every time this particular strings in the result thing. Okay, and whenever this result will become 2 into n, the length of the result, we will be written from that, right? So whenever your result dot length is equals to uh 2 into n, right? 2 into n. So you need to do what? You need to print it out. First of all, what task you make, you need to do whatever value in the inside the result, you have to print out, right? So I'll print result. Okay. The second thing that you have to do from here is what? Return, because this is what my base case. Okay, right? Second thing that you have to do is what? Your recursive call. Okay, so there will be two recursive call from here. One is from the open one is from the close one. Okay, so every time you have to check whether my open is less than n or not, because if my open is equals to n, I need to backtrack, right? If my open is equals to n, I need to do what? I need to backtrack, not backtrack actually, I need to close everything and I need to become this close to open, है ना? So whenever my open is less than n, then only it should happen, it should enter in this, right? ठीक है guys, are you able to understand me? You able to, yeah, are you with me guys? Because I'm not able to see your chat right now. Okay, ठीक है. So now open is less than equals to n, open is less than n, then only you have to do this task, right? So if your open is less than n, then you need to do what? First of all, you need to result dot push opening bracket, right? Okay, है ना? Okay, and after this you need to call again, you need to call your function again. So whatever the print parenthesis function is, you have to call again this will be my recursive call. Okay, whatever parameter will be, you have to call this function again, right? And after this, what you need to backtrack. That does mean that what? Result dot pop. See from here, see what we did after we got here, after we did this particular task, not here, after we got this particular task, like after we printed this, okay, at this particular point of time, our result dot length would be equals to 2 into n, right? So we'll print this particular entire thing, we will backtrack, and again we will check whether our result is equals to, like our open is equals to n or not. If not, we will again backtrack. So backtrack, that does mean what? We are popping out, है ना? See, this was our last character, है ना? This was our last character. If you pop it out, this will be your second last character. Again we have to pop out, again we have to pop out, again we have to pop out, till the time our open it will be not equals to n. So that is why I have written here result dot pop every time. ठीक है? Okay, this was our first part, and the second part would be what? Simple one, about the close one. So close should be always less than open, है ना? If my close is equals to open, then I'm done, right? So my close would always be less than open. If this is my less than open, then I need to do what? I need to push first of all the closing bracket, है ना? Then I need to call this again. I need to call this again, print parenthesis and result dot pop to backtrack. This is what our code would be. Okay, right? This is what our second step and third step also, because after calling we did also our self work, है ना? We did two time of self work. First of all here and second here, है ना? ठीक है? No, no need. It should be less than only. It should not be less than equals to, because whenever my closing bracket are equals to n also, I need not to do anything, है ना? See here, whenever my opening and closing are equal, I need to know not to do anything, right? So that is why I did not use equals to here. So everyone can code this now. Everyone will be code now, right? Can they are able to code? Yes or no? Okay. So please code it. I will be giving you 10 to 15 minutes for this. Okay. Didn't get pop part. Okay. Priyanshu, see. Priyanshu, uh, see. After this, see, whenever we are getting this particular solution, okay, we are reaching 2 into n, है ना? But we have to print another solutions also. Yes or no, Priyanshu? Right? This is only one solution, right? This is only one solution. Now to get another solution, what we need to do? We need to make a step at which our open will be not equals to n, है ना? If my open is equals to n, then I cannot do anything apart from closing, right? So if I have to explore the possibilities, I need to go till the point of time my open will be not equals to n. That does mean to this particular case. So if you want to pop it, if you do pop it out, if you do pop, then your last character would be removed, right? Again you will check the condition, this will be not meet, you will be again pop it out, you will be again pop it out, right? Yes, pop will be the last one. Okay. Okay, so every time we use recursion, we should draw a tree to the base case, right? Yeah, exactly, this is what our, like, we draw on the tree now, this is what our tree is. Aishwarya, now this is what our tree look like. It is pretty much complex here because I my writing are big, otherwise it will be clear win. Okay. Okay, so keeping this particular point of view in your mind, and this particular algorithm in your mind, try to code it out. If you cannot, I'll be there to help you out, and I'll be there to code. Okay, if many guys are saying that we need to code, I'll code it out, but I'm giving you some time to understand the question, to get through the question, to think about the possible solutions of it, and then after code it. Okay, we are not in hurry. Okay, we are lagging some problems, but no problem, we will take some more time to solve that, but I want everyone to be clear with this particular problems. Okay. Okay, if I want, then I was also like, I can also code this, okay, right now. But if I'll code this, you will be not understanding it, so I'll give you some time to get digest this problem, what the approach we did, and the code we did. ठीक है? हाँ ना, yes तो बोल दो यार. Yes, no, everyone. Everyone, there are 50 people here. Okay, I want answer from everybody. I do not want anyone, any single person would be asking me the doubt. I will be explaining till 1 a.m. Okay, trust me, I'll be explaining till 1 a.m. Okay, fine. So please try. I will be there for you every anytime. Okay, Rupesh, can you please raise your hand? Okay, fine. Meantime, other people can try it out. Okay. Yes, Rupesh, please tell me
Yes,
which
yes, hello,
particular
sir.
point of time you are facing difficulty.
Actually, sir, the problem which you took on Monday, I have a bit confusion in that as well. So I guess I am confusing that problem with this problem. So once, if possible, if you can explain the whole flow again, I have got the story what you tried to explain, like how the
Mhm.
parenthesis will be there, open, close, those things I got.
Okay.
But the solution, if you can explain me this steps again, then it would
Okay.
be much better.
Okay, fine.
Yes,
See, surely.
yes.
See, first of all, you want me to explain this one. Then after we'll move to the Monday one. Okay. Or else Monday one we will do in the doubt session, and this one I'll explain right
Yes, sir,
now.
yes. Yes.
Will it
Monday
work?
one we can do it in the doubt session. Yes, yes, yes. I just need this
Okay.
explanation. Yes, sir.
See,
Yes. Thank you.
first of all, you have to clear with this base condition. Base condition, that does mean that where we are stopping. Okay. So if you see, every time
Okay.
we are stopping our flow whenever we are reaching the length of 2 into n. Okay. If you count the length of
Right.
here, that is
Yes,
3
sir.
and the 3 6, right? Here it's 3 into
Yes.
2 5, 3 and 3 plus 2 is 5, right? So whenever we are
Yes.
reaching 6 number of lines, that is what, 2 into
Yes.
n.
And
Whenever
right.
we are getting this, we are stopping, right? You
Right.
know, this will be our base condition. So when I
Right.
just wrote that, whenever my result dot length would be 2 into n, it, I need to print the solution and into return,
Yes.
right? This result will be holding the this value. Every time it will be holding this value. Okay, whatever our
Yes.
value we are having in the tree, it will be having in the result. It is my array, है ना? I'll write the
Yes.
code, you will be much more clear by this. Okay, now this will be your base case. Okay, now my our second observation was what, that whenever I just have to do the task if I have my open like op was less than n. Yes or no? If my op is
Right.
equals to n, then there is no sense of writing anything, right? I just need to close it
Right.
after this, and if this condition met,
Yes.
then I just have option of closing only, है ना?
Yes.
So I can do anything if I just have this condition op less than n, correct,
Yes.
है ना? So that is why I just return the condition op like open less than n. You can also write it like op, ठीक है? Here I took the op example, here
Yes.
I'll taking the open, though this both are same, okay, don't confuse in that, fine. So
Yes.
if this condition met, then what I need to do, see, if my condition like whenever my op was not equals to 3, I'll zoom it out
Sir,
like
one
this
more
case.
small doubt. Sir, one more small thing. Just suppose if I've opened two open brackets, after that I cannot use three close brackets, right?
Like this, no, you
Yes.
cannot, this is not valid parenthesis, right? This is not valid
Okay.
parenthesis,
Okay. Got it. Got it.
right? That is why.
Yes.
Okay,
Yes. Yes,
now
I
see
got it.
here,
Yes.
from this you can, my op is equals to 2, so what you can do, just close one, right? Because one time we have opened, one time we have to close.
Sir, your screen is freezed, I guess.
My free screen freeze right now, what about now?
Yes. 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 Now I can see. Yes.
See, here my op was 2, I just need to close it now because one time I have opened, one time I can close,
Yeah. Right.
right? So whenever my open less than n, can I say I need to open, like I need to push this,
Right, sir.
right?
Yes.
And I need to call it again, right?
Yes.
है ना? And after this I need to backtrack if I any other solution I can implement or not, like this. I need to backtrack it till the point of time I will not reach to op equals to 2
Right.
or
Yes.
1, है ना? है ना?
Yes.
And after this I need to check if my close is equals to n or open. Can I say I am done with my task? I cannot do anything because my
Yes,
open
sir.
is also 3, close is also 3.
Yes.
है ना? I need not to do anything. I
Yes.
can only do anything whenever my close is less than open, and that too, I need to just close one, right?
Okay.
है ना?
Yes.
Yes or no?
Yes.
Getting it? And the
Yes.
same
Yes.
operation that we did in the open. That's all. If it
Okay.
reached
So
the base condition, it should return. That's all. That is the scenario.
So these two steps, the last two steps are what inside each block, like print parenthesis and result pop this.
Like which part you want me to say?
Yes, yes. These two
This
steps, what
part
you have done.
this part is recursive call. This is what our self work. This both
Okay.
our self work. This is what our
Hmm.
recursive call, and this is what our base case.
So return pop means you're printing that line, right?
No, we are
Okay.
not
Okay.
printing that line. We are backtracking so that we can print it another thing. Okay.
Didn't get, sir.
Okay. See,
Okay.
see, I'll explain you. My screen is visible to you because I'm zoom it.
Yes. Yes,
Okay.
sir.
Okay. So see, after this particular point of time, whenever we reach 2 into n, right, we
Right.
do not have anything to do. So, but we are left with this particular solutions, right, to print it out,
Yes.
right? So we have to backtrack till the point of time we will not reach op equals to 2. So that does mean that why we are doing here, why we are popping here, is we need to print another solutions as well, है ना?
Yes.
After printing this one we need to print another solutions as well. This
Yes.
line would only be executed when you are like whenever you are getting response from this. That does mean that
Mhm.
like suppose a into b with Dipanshu, he is
Mhm.
passing b to you, right?
Yes.
And A is left with Dipanshu, right? But
Yes.
Dipanshu will add this A whenever you are returning this B, right?
Yes.
है ना?
Right.
So this pop task will only be done whenever you are getting response from this. Can I say that?
Yes. Right, sir.
You know?
Yes.
And why we are doing that, because we need to print another solutions as well. We don't need to just one solution, right? We are not stopping
Right.
with the one solution.
Yes.
Okay? That is why. If we are like when we are writing the code, actually you will be much more clear.
Okay. So, sir,
Okay?
these two steps you want us to write, right? Like print
No,
parenthesis inside that.
I
Okay.
want entire thing to write.
Yes, yes, that I got it. But entire picture is clear. But these two lines are the whole. I
Yeah,
mean,
whole like heart and soul of the problem.
yes, yes. So this,
Okay,
the second, the middle line is
recursive
recursive
call,
call, right?
and this
Yes.
two are my self work. This self work will be done before
Self-
call. This self work could be done after call.
After call.
ठीक है?
Okay, sir. We will try it. Yes, yes. I
Fine.
got the clarity.
ठीक
Thank
है,
you, sir. Thank you
ठीक है,
so
yeah.
much.
Welcome. Okay, so what is the status, people? Have you all have tried? What is the status, people? Trying ना? ठीक है. Shivam, you are always fast. You're very fast from the last couple of sessions. Great. Nice. Nice to see that. ठीक है. Everyone else, please try this. No problem. ठीक है. We are not we are not here to compete with anyone. ठीक है. So don't try to implement solution fast. Try to implement solution that will be bug free. Okay. That is what our aim is. Fine. So I am giving you some time. Please try to print it out. After some time, I will be like I'll open my browser and I will actually write this code if you cannot. Fine. Chalo, awesome. How many of you are still trying? Still trying? That's fine. And Ekta, Dipanshu, you guys are getting output right now. It's printed now. ठीक है. Okay, fine, no problem. So for those who are still left, please try along with me. I am sharing my screen so that everyone can print it out. Right? Let me share it. Let me know once you can see my developer console. ठीक है. So yeah, for those who have already did getting some confidence now with recursion. ठीक है. It's easy, it's hard. Those who understand, it's easy. Those who cannot, it's hard. ठीक है. Just motto is to feel you confident. Okay, you have to have the confidence if you are trying the solutions. Okay, okay. So I'll write my function as like print valid parenthesis, print valid parenthesis. It's very big. Let me make it short. Print parenthesis. And after this, I will take my parameter as told as analysis part, signature part. This is my result. Then I have my open counter, close, and number of n. Okay. Just a second. Yes, like this. Now I'll write my base case. Base case. In this, I'll write result dot length. If it's equals to 2 into n, then I need to do what? I need to console it out, right? So I'll do what? Console dot log result dot join. This is just for joining purpose. Okay, result dot join, and I'll just return from this. Okay, cool. And then after I'll write my conditions. Open is less than n. Then I need to do what my recursive call. But before that, I need to insert result dot push opening bracket. Then I have to do my recursive call. Okay, I'll make my recursive call with n plus one. Open plus one. Sorry, not n plus one. Okay, open plus one. Okay. And after I'll do my pop dot pop in the else part. In the else part, I'll do the same exact thing with some different parameters. First of all, I need to close it. So I'll make it close. Not else. It's like if again, I need to make it my condition. Close is less than open. Okay. I need to close my bracket. I need to close plus one and the same thing. Okay. And I'll just call it out. Call this particular function result dot, yeah, this one. Okay. So result will be what? My empty array. Okay. Open would be my 0, close would also be my 0, and n would be, let's say I'm making for 3. Okay. Let's see if it's printing or not. See for n equals to 3. uh yes, this is what we have discussed. Yes or no? Right? Okay. Pretty simple. Let's try with 4. There are very big solution. Okay. Let's not go with this. Let's try with 2, the smaller value. Okay. Vaibhav, did I not teach you what is join doing? Like join is the same thing. Okay, see, join is not no like hard and fast. Join is what, just doing the, like just joining the every combination of your array. Okay, every element of your array. If you just see and read about the join, you will make it clear. Let me just first of all tell you. Okay, if I'll just cut it out, let's say if I have my array 1, 2, 3, right? If I just need to join it, let's say if I join, it will be on a string part. Okay, let me do console dot log this. Okay, it will join every element of it, and it will join by comma. It will make a entire string only. Okay, this is what join will do. Fine. Okay, Dipanshu, I'll debug this. Debugger, not here. We will make debugging in another tab in Chrome. Let me open my Chrome. Let me see what is my Chrome. This is my Chrome. Okay, fine. Let me share it now. Just let me know once you can see my developer tools of the Chrome. Can you guys see it? Can you people see that? Okay. Okay. So this was my code. Let me debug this. Cool. Okay. So I'll go inside my parenthesis. My result is what? Empty array. Open is what? 0. Close is what? 0. N is what? 2. Okay. Now I'll first of all check length. Result dot length is equals to 2 into n. It's not. We'll go into open. Open is 0. N is what? 2. It will be true. It will push opening bracket. Okay. It will call again the same thing. Okay. It will call again the same thing. But this time my open would be what? 1. है ना? Okay. Because I have inserted my this one. है ना? Right. Now I will again check whether my 1 is less than 2 or not. It's not. Okay. So it is, so it will enter in this. It will push again the opening bracket, right? It will call again. Now this time my 2 will be less than 2. This will be false. Okay, that does mean that my open is equals to n, है ना? So I need not to do anything else. Yes or no? Right? Okay. So after this I just have an option to close. Consider that my n is 2, not 3 here. Okay, so don't confuse in that. Okay, I just have n equals to 2. Okay, so I have two opening bracket. After this I do not have to do anything else. So I'll move to the close part. In the close part, my close is what? 0, because I did not do anything with the close. Open is what? 2. Okay, so I'll close it until my close equals to open. Okay, so I have closed that. I'll make this function again. My close equals to 1. Note here, I'm focusing now with the close, है ना? Here I was focused on the open. I was focusing open counter till the point of time it will become n. Now I'll focus till the time close will become n or open. Okay, right? This will be false. It will be again insert what? Empty parenthesis. Again check this with the close plus 1, right? So now my close and open both are equals to 2. So can I say my result dot length is equals to 2 into n? That does mean what? 4. This is what? 4 to open to close. Yes or no? Right? Okay. And if you see the call stack, just a second. This is what my call stack will look like. Okay. This will be just end of the process of this particular process only. Okay, where n equals to 2, close to, open to, and this is my result. Okay, this is what just the process of this particular part. It will return from this. Where it will return? Wherever it was called. It was called from here. Okay, this is what the basic necessity of the recursion, right? है ना? Okay, if I press this return, it will be popped out from this call stack and it will return this particular result to this. Okay, yes or no? Right? Okay, see here. So Dipanshu, Deepak, okay, Deepak, we are using pop when we are returning. Okay, till the point of time we are just calling it. Now we are focusing on the return part. Now we are just popping out. So if you see my result right now, it will be looking like this. We already consoled it for one time. Okay, here. So if you see the console, it is already been printed like this for first string. Okay, okay. Now we are popping out the last term. Fine. We will pop out the another last term. Okay. Then after it will go here because this will be returned to this particular call. After this call, we will be popping out. So it will pop another one. After we will check. Now see my open is what 1. Open is not 2. Till the point of time it was open was 2. है ना? That is why it was popping out. So now my open is what 1. It will not pop now. It will again check this. And it will insert the closing bracket. Again it will call the same thing, right? Okay. My open is still 1. It will again insert open. Again call. Now my open is what 2. You know? So I have to move to the close part, right? So it will close. It will call again. Since this point of time I open, so result dot length is what 4. It will be true. It will return from this. This is how it is happening for entire solutions. Okay. Do I need to debug everything, people? Because it will be a very lengthy process. Deepak, we are taking that much of parameter. See here, we are taking this much of parameter because we want result, right? We want our result to be printed out. So this one parameter. Open and close is what my counter is. You can also take this counter here also inside this also. That's also you can do now because we are and this is also my end. So you can also modify your code like this also. See, this is very good catch. You can also modify your code like this. Instead of taking this parameter, just call this no parameters. Okay, and here we'll do this. Like this result is equals to this. But see, yeah, parameters are necessary because if we are not doing this, every time our function will call, it will be empty value. Okay, if I declare this value inside the function, it will be my empty value. And that is why we are doing this. Okay, Deepak, Priyanshu, we still need to pass n also. We should need to pass this also because if we are in if we are making this declaration here, then every time in the recursion when our function will call, it will our value will be reset. Okay, Likit, we are using the pop because after this particular calling out, after this particular calling out, we need to print another solutions as well, right? So for an example, see, if you consider this solution, then first of all we printed this, right? Then after I need to make a solution. See, this solution will only be possible if you pop this particular point it out. Like if you see, if you pop this values out, है ना? When my open this is in this particular solution, like in this one, my open is 2 and close is also 2, right? Ah, so I need to find some other solution. If I need to find some other solution apart from this one, then I need to get to the part where my open will be not equals to 2. It should be less than equals to less than n only, right? So see here in this particular solution, in this solution, it was popping this much. Okay, after this solution, it will be popping this value. This, at this particular point of time, my OP will be 2, right? But I don't need 2. I need 1. So I'll also pop this. I'll close it. Then after I open it. Then after I close it. Okay? This is pretty much simple. These values need to persist through all function calls. Yes, that is it. Okay, Likit? I hope am I clear with everyone, not just Likit. People, am I clear? Okay? Okay. So I will just copy this particular code and I'll paste it out in our VS Code. Today's date is 15th of June. Recursion problem solving. Okay. So now, if we are clear with this, if we are clear with this, yeah, yeah. Okay, fine. So yeah, it's a perfect time for dinner. Okay. So please take a. We'll take break for around 10 minutes. 10 minutes would be fine, people. 10 minutes would be fine if with everyone, or 15 you want. ठीक है चलो 15 ले लेते हैं no problem. So uh, we'll take for 15 minutes break, so it's 9:31 almost. We'll be come back at 9:46. Okay, we'll be back at 9:46. So take your dinner and come back. Welcome back, guys. Am I audible? Am I audible or not? ठीक है. So, just a second. Let me grab my tab. Okay. So now, everyone is back, people. Okay, ठीक है, चलो. So, uh, actually, the thing is, whenever I zoom out and zoom in, like this, and then after if I print this out as a PDF, I export. It's somehow it's cutting like sometimes. I'm not sure why. ठीक है. Anyway, the second question for today is very simple. Let me give you the tiling problem. Okay, it's something known as the tiling problem. ठीक है. Have you heard about this before? No. ठीक है. ठीक है, चलो. So what does this problem says? What does this problem says that you will be given out. You will be given out the two things. Okay. So uh, the first thing that you will be giving out is first thing that given a 2 cross n board. ठीक है. 2 cross n का एक बोर्ड होगा that you will be giving out. Okay. Also, you will be giving out the tile of size 2 cross 1. Okay. So the question here it is that sir, please count the number of ways to given board, number of ways to tile given board. Okay. And there is also one constraint that is you have to use using 2 cross 1 tile. Okay. So for those who did not understand this, what does this mean that 2 cross 1 tile, right? So this means that there are two placements. Okay, there will be a two placement for this. First, that is horizontal. Either you can put the horizontal tile, either you can put the vertical tile. If you put the horizontal tile, then it will be look like something this. Okay. If it's horizontal tile, it will look like this. Okay. This is what my 1 cross 2 tile, my 2 cross 1 tile. Either way you can use. Okay. You can use anything you want. Okay. Now you can consider that like in your home also we put some tile, right, to fill our floors. So over that also, so you can consider that like we have to fill your floor and we have to put tiles of 2 cross 1. We cannot put tile in random order, है ना? That's the same way we are doing in our home also. We are not putting our any tile in the random order. We are following some specific fashion in that we are putting our tiles. ठीक है, right? Okay, now. So for example, if I have my n is equals to 4, for an example, let's say if I have my n is equals to 4. Okay. So for this particular case, what will be I told you that I will be having what, 2 cross n board. Na? So my size of board would be what, 2 cross 4. Na? 2 cross n size of board that I had. Okay, in the question itself. Okay, in that I have my board now of 2 cross 4. Yes or no? Na? Right? Okay. So this will be look like something this. Okay. This will be look like this. So in this particular placement, in this particular board, you can place your board in a way like you can place your tiles like you, how many ways you can place your tile. Okay, this tile if you have, this two tile if you have, how many ways that you can put and you can fill this board. Okay, that you want to find. Okay, okay. Question is clear. Question is clear. What is expected in the question? No. Suraj, you are given a board of 2 cross n. Okay, right now I told my n is equals to 4. This is our board. Yes or no, Suraj? है ना? In this particular board you have this tile, either you have this tile or you have this tile, like this is the same tile but either you can put in horizontal or in vertical, and you have to fill this particular floor. So there will be how much possibility you have, you want to find it, right? So for instance, if I put every tile in vertical, then this is my one possibility. Every tile I will put in a vertical mode, right? Okay, okay. So this will be my first possibility. All tile in vertical, है ना? All tiles in vertical. ठीक है? The second way that I can follow here is what? Let me draw it. Like I need to draw every time. Okay, so it will consume a time, but it will be clear if I draw it. Okay. The second thing that I can do is put every tile in vertical mode. Sorry, in horizontal mode, right? So like this, I can do it. This will be my second way, right? है ना? Right? ठीक है, people? Yes or no? ठीक है? The third way that I can do, people, everyone is with me right now. Here we put all tiles in horizontal. The third way that I can follow here is uh, I can put two tile in vertical and two tile in horizontal. है ना? So that does mean that can I do this like two tile in horizontal like this and two tile in vertical like this. Sorry, this is vertical, this is horizontal. Okay, so two tile in horizontal, two tile in vertical. Okay, this is my third way to do. The fourth way that I can do here is what? I can put two tile in horizontal. So the only option left is what? Two tile in vertical. The reverse of the previous one. Na? Right? So this is a combination. These two are the combination of what? Two horizontal, two vertical. Yes or no? Right? The fourth thing that I can do here is Yeah, I can do something like this also. Okay, I can put one horizontal, two, sorry, one vertical, two horizontal, and one again vertical, right? Can I do that? ना? This can also be done, right? ठीक है, right? No, diagonal we cannot place. Okay, diagonal we cannot place. So if we count the total number of possibility, if we count the total number of possibility, then see, we have this three, we have this three, and we have this two. So total number of possibility are how much? Five one, right? So for simplicity purpose, what I'll do, this is my, this was my third one, this was my fourth one, this was my fifth one. Okay, so to placing horizontal plus like horizontal plus vertical, these are my three one, plus all or vertical or horizontal, so this was my two one, so plus one, this will be what, my five. Okay, yes or no, right? Okay, so suppose karo, if I give you the question n equals to 3, then how many ways I can place these tiles? This is your question. Okay, okay, how many place, how many ways you can place this tile? This is your question. Can everyone do it? Put your pen and like take a pen and paper and tell me how many ways you can put this tile. Okay, if I'll take n equals to 3 and the same board is that. Okay, same board, that does mean what, 2 into n. Okay, same board and same tile. Okay, tile will also be like 2 into 1, horizontal or vertical, that is up to you. Everyone can do that. Okay, yes or no people, everyone? Yes, no, कुछ तो बोल दो. लंच करके डिनर करके आए हो अभी यार. Like you have taken your dinner just now. ठीक है, show some energy. There are almost 52 people right now. Hello. Yes, no. I want this to be interactive. Huh? Fine. ठीक है. ठीक है. So please do it. Okay. Yes, Priyanshu is right. There are three. Suraj, can you please like okay, fine. Just a second. Just a second. So Suraj, what the question is, we will have okay, no worries. If you have a network issue, if you will have your n equals to something like n equals to three or what, you will have this board two into n, and you have this tile two into one, right? So you need to place this tile in the board. This is what the question is. So now for everyone else, those who have tried, those who have not, this is pretty much simple. So we have n equals to 3, 2 into n is our board size. So what will be our board size? 6 1, right? 2 into n, like 2 into 3, right? There will be 6 boxes like this. Okay. So how many possible way you can place this tile, horizontal or vertical, in this? Okay, that is what the question is. So either the thing is we can put it in a vertical mode like this. We can put every vertical, and another way is to put everything vertical, sorry, everything horizontal. Like no, not horizontal everything, we cannot put every horizontal, like we can put two horizontal and one vertical, like this is one of the ways, right? Okay, what else I can do, what else I can do, either I can put one vertical, two horizontal, just mirror image of that, right? Okay, so there is no other way, right? So our possibility of total is what? Total possibility are what? Three. Three ways. Yes or no? Two horizontal we already placed Nilanjan here. है ना? So if you observe in this particular question, if you observe while putting this tile, if you are observe like if your mind is like open, then what you will do? See, first of all, suppose करो कि I placed everything vertically. Okay, I placed my tile vertical. So can I say my I'm left with what? N minus one mode, है ना? Can I say? And if I say that I put one tile vertical, so that I have to put another tile vertical only. Like I put one tile horizontal, I must put another tile horizontal only. I cannot put this tile vertically, है ना? And if I do that, I'm left with what? N minus two. Yes or no? Dipanshu, that's a great catch. I'm pretty impressive with this. That's a great catch. It's a similar of this. Okay. Okay. Nice. So can I say that every time I will sum n minus one, n minus two, and I'm done? And what will be my base condition here? My base condition is pretty simple, that whenever I'll have what n is less than or equals to 2, I should return n. Okay, this will be my base condition. How many of you people are clear with this? How many of you are clear with this? Done na? ठीक है? How about everyone else? Priyanshu, Deepak, where are everyone? Easy ना? Yeah, ठीक है, ठीक है, great. चलो. So, do I need to explain this? Like, do I need to code this? This was a pretty easy, right? है ना? Do you want me to code? Yes, no, no. ठीक है, चलो. Okay. So, धीरे धीरे confidence आ रहा है ना everyone? है ना? The moment we solve more problem, the same amount of the same level of confidence you will be having in your subconscious mind. Okay, you will be pretty much confident that at least you can try it. Okay, and like if you try 2 to 3 times these things, you are done. Like you can do any problem with recursion, not any but like most of the problem. Okay, yes or no, agreeing with me, those who are actively doing the problems? Na Ekta, you are getting some confidence now. In the two sessions back, you told that you are not that much of confident, है ना? ठीक है, ठीक है. Slowly and gradually we will be progressing. ठीक है. The next question we will target now. It's also the easy one for you guys. I'll not like I expect some of some of you guys can able to solve it. ठीक है. Fine. So now my next question is the lexicographical order. Have you heard about the order, lexicographical order? Anyone? ठीक है. So what I'll do? If you remember, we learnt about the sorting, है ना? So let's say if I have this one, two, three, then I have 11, 21, and 4. This is what my array is. So guys, please tell me the answer of array dot sort. What will be the answer of this? What will be the answer of this? Shivam, please write the entire array. See, I can see the comment section are divided into two section. One guys are telling me that this is will be the simple answer, like 1, 2, 3, 4, 11, and 21. The second one are telling me that it should be 1, 11, then what? 2, 21, 3, and 4. This will be my answer. Okay. So see, if you do array dot sort, you will be having this answer, this as your answer, because it will be internally the making this as a string. And if you compare the two strings, this will be like in between this and this, every time your first letter would be compared. Okay. So if you do like this, so if I'll tell you that you have a number 15, okay, so you need to print till 1 to 15 in a sorted manner, है ना? So what it will, how it will get printed? 1, then 15, then 2, 3, 4, 5, that like this. Okay. Okay. This is what something called as lexicographical order. So if you just use this function, you can able to print this lexicographical order. This is nothing but it is called as lexicographical order. But in this particular scenario, we don't need to use this. Okay, this is not allowed you to use. Okay, so if I pass this as my input, 1, 2, 3, 11, 21, and 4, my output would be look like something this, like 1, then we have 11, then 2, 3, sorry, 2, 21, 3, and 4, like this. I need to make my output. Okay. Okay. So it is like sorting on the basis of first digit. Okay. So before sorting, everything was converted into string, like in array dot sort. Okay. So before sorting, everything was converted into the string. That is why it was doing the like it was producing that output. Okay. Now what will be my problem statement here? My problem statement here, it's like for many people it would be much clear that you will be given a array. Okay. You will be given an array, and you have to generate all number. You have to generate all numbers up to n and print all of them in lexicographical order. Okay. Okay. This is what my question is. This is very clear. I return that very clear that whatever number I'll give, first of all, you have to generate all the number up to that number, and you have to print them in the lexicographical order. There are two tasks here. First of all, you have to generate all number up to n. Second task is you have to print them in lexicographical order. I hope I'm clear with the problem statement. Okay? Yes, no, people. ठीक है ना? Okay. So suppose करो कि I am allowing you to print in a I'm allowing you to use the sort method. Okay, I'm allowing you, every one of you, to print the sort method. So it is pretty much simple na. If I'm allowing you to do that, okay, you have to think about in a homework, as a homework, how to do that without using the sort method. Okay, you have to think about it. So right now what I will do, right now what I will do, I just write one simple program that I think so every one of you will agree with me. Where is my, like, why every time it's happening? I need to open my Mozilla again and again. I hate Mozilla. Just a second. Okay, fine. Can you guys see my developer tools of Mozilla? Yes, no. Okay. So what I'll do the simple thing. Uh, let's say, see, I have three tasks. First of all, I have a task of creating an array of the number what I having. ठीक है, what the number I'll pass, let's say I'll pass 20, then I need to create first of all 1 to 20, yes or no, है ना. Then my task is to what, to print them into lexicographical order. So first of all I need to convert them in lex order, yes no, है ना. And then after I need to print it, ठीक है. So the better approach, like this is a simple question, but what I will do, I'll show you some optimized approach for this. Okay, some optimized writing a code in an optimized way, so that you will be stand out in a with everyone else. There will be a great competition when you are giving you interviews or when you are performing with someone else. So if you're writing the code like this, you will be stand out automatically. How? I'll just show you. So first of all, my three tasks are there, right? First task is to what, create an array. Okay, so in that I'll make it as my arrow function. I hope you remember array, like arrow function, है ना, every one of you. Like as we move forward, you don't have to vanish the things what we have already learned. Okay, you need to revise every time, है ना. I'll not explain this every time about the arrow function and all. We have in depth learned it. Okay, so now my const, I'll generate number. So I'll make the empty array first of all. Then I have to make a loop. Let I is equals to 0. I should be less than n I plus plus. Okay, this is what I have to do. And I'll just do what, numbers nums dot push. Every time I'll push I. So by using this, I have generated my number, है ना, return nums. So by using this, I have generated my numbers, whatever I'll pass. Yes or no, है ना, ठीक है. Now, now after that, what was my task is to arrange it in a lexical order. Yes or no, है ना, ठीक है. So I'll again create another function, lex order. This will be again my arrow function. I'll pass nums array in this. Okay, and in this I'll not do anything much. I'll just do sort and I'll just return nums. Okay, so it will generate everything in a lexical order, right? Okay, and then after what my task is to print it out, right? So I'll just what, print values is equals to nums again my array, and I will just print it out in a like a string mode. Okay, so I'll just make an empty string, that I'll just make a loop. Let I is equals to 0. I should be less than nums dot length plus I will be having str is equals to sorry, str plus equals to be honest, nums of I plus, then after I'll just make a space, okay, to print it in a better way. I'll just print it out after it, console dot log nums. Okay, so if you see here, I have divided my task into subtask, है ना. So if suppose करो कि in your program anyone wants to print the values in a from the array, ठीक है. So this function can be used no matter what your question is, है ना. No matter what your question is, if I'm just passing this array, it will be getting printed out, है ना. So this is something called as loosely coupled. They are not dependent on each other, है ना. This is not dependent on each other. If you just pass any array, it will sort it out. If you pass any number, it will give you the numbers till that particular point. So these are something called as loosely coupled. We have not used one thing in another. Yes or no, right? Okay, I'll just define now. Let n is equals to, let's say, 22, like this. If I want to print it out, then I have to just call this particular function of create array. It will create my array. Okay, it will create my array. Let's say let array. Okay, I will pass this array in lex order. Okay, so lex order, I'll pass it out this entire array. Okay, whatever output of this I will pass in which one into values. Okay, let's see whether it's generating output or not. See, it's generating my output 0, 1, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, not 20, then 2, 20, 21, 3, 4, 5, 6, 7, 8, 9, 10. It's correct now? Perfect. Okay. So we had this loosely coupled architecture. If you have heard about the loosely coupled architecture, है ना? Tightly coupled architecture are not followed anymore in industry, है ना? So this is what that does mean, like loosely coupled. This is what the shortest term in that simplistic way. Okay. Okay. Now, as a homework, you need to think about that how we can do this same process without using this sort. Okay. Yes or no? Okay. ना? ठीक है चलो. Got the solution now. It was pretty simple. It was so simple, simplest solution of of the problem solving that of those we have just now learned about, right? ठीक है चलो. So we will be moving out with another example. My screen is visible for everyone. ठीक है चलो. Then my question here is, uh, let me think what I can give you. My question here would be, yeah, this one. This is very simple question again. So since we have covered tiling, since we have covered lexicographical, parenthesis, subsequences, and calculate the binary number. Now the only thing that we are left with is the permutations. Okay. This is also a significantly simple question, yet the tough question what everyone fills out. Those who do not understand the what we can say logic. Okay. If you got the logic, this is what you can do on your own. Now I'll give you time now to do it after explaining the logic. Okay. I want answer from every one of you. Okay. If I'll not getting answer from anyone, I will no randomly unmuting anyone and I'll ask the logic of it. Okay. Will it work? Because I feel that this is pretty much simple. I'm pretty much sure every one of you, if you have concentrated little bit also, you can do it. Okay, fine. This is pretty interesting question. Just be with me. The question is pretty much simple. Question says that you need to calculate all permutations of an input array. Okay. Now, now suppose our input is I'll give you as A, B, and C. Cool. Okay. Your output that you want, that you need to print it out for me, is A, B, C. Just a minute. Output that I want from you, that A, B, C, then A, C, B, intersynthesis 2, then B, A, C, then C, A, B, then we have B, C, A, and the final one that we have C, B, A. Yes, correct. This one. Okay. So I want this entire thing in your output. Simple है. ठीक है. You can relate with some other problem that we already did, not today, yesterday also. ठीक है चलो. We'll do one thing. I'll give you some time. I'll give you some time for this. So you want me to give you some hint of this for this? See, what does mean by permutation is like permutation of any string. That does mean that you have to generate all possible words, okay, that you can form by rearranging the character of the what the provided string is. Okay, so suppose karo ki if our string is what uh, AB. So out of this AB, suppose karo ki if my string is AB, so out of this AB, what you can generate? First of all, the AB. Second one is what? BA. Okay, you have to interchange the word. Okay, so by using recursion, how we can solve it? So another hint that I will give you. See, when I'm like जब मैं hint देने पे आता हूँ ना तो like I have that problem that I'll explain entire problem, but I'll keep it that in mind. I'll just give you hint for this time. Without repetition only. What do you mean by that? Anyway, suppose if I have AB, okay, by using recursion I want it. So suppose करो कि Vishal have this AB. Now what Vishal will do? Vishal will say that suppose here it is with Vishal, okay. Here it's Dipanshu. Here it's Ekta, okay. Now what this the guys are doing is Vishal. What Vishal will say? Vishal will keep A with him. Will pass B with Dipanshu, okay. There's no need of a third person here. So he will pass P to Dipanshu. He will tell, "Hey Dipanshu, please find every possible permutation of B and return to me. Then I'll take care of it." ठीक है? ठीक है? Fine. So Dipanshu के लिए तो ये लॉटरी लग गई because what he can do with the single character. ठीक है? He will just return as it is. You will have your B. Okay. So whatever Dipanshu have given to Vishal, he will just add A to it for one time with here, one time with here. Combine these two and return to me. That's all. The smallest form I have just explained. Okay, smallest form I have just explained. If you have concentrated enough, then you will get the solution. Okay, I'm giving you some time to everyone. I'm giving you like a good amount of time, 10 minutes, hardly 10 minutes. Okay, and I want answer from you. Actually, I have explained the logic. I just want the refined logic from you. Okay, can I expect that? Can I expect that? I'm repeating once again. What I just spoken about is Vishal, what Vishal did, Vishal keep the A with him, keep the first character with him, passes the B to Dipanshu. Now for Dipanshu, it's like not less than lottery. He will return the single character because from single character, what Dipanshu will do? He cannot do anything else, right? He will just return as it is because from B he cannot generate any other character. है ना? ठीक है? He will return as it is. Now Vishal, what Vishal will do? Whatever character Dipanshu will give to him, he will copy that particular two thing, ठीक है, B and B. One time he will add A whatever he had before the getting character, one time after it he will combine these two. This is what the answer is for string AB. ठीक है? Yes or no? Am I audible? Anyone got it? ठीक है? Okay, so I'm giving you, now I'm just giving you 5 minutes because I have already told the logic. Okay, now I want from you to have the same approach to be implemented with the three string. Okay, okay. So now take your pen and paper or take your computer and try to figure it out how the same concept will work whenever we have three string. Okay, and what will be my base case? At least I need to know this from everyone. Right now it's 22 40 like 26 like 10:26. We will be back at exact 10 minutes like 10:35. Okay, approximately we'll be back at this time. Okay, ठीक है? do your work. Guys, question clear है ना सबको? Are you are on right path ना? Question is clear for everyone. What is expected? ठीक है? Yes or no, everyone? There are almost 52 people in this class. Please be interactive, people. Otherwise, you would be in the loss. ठीक है? Everyone would be in the benefit, but you would be in the loss if those who are not responding. ठीक है? Your batch is really good. So keep that repo till the end of the session. Okay? Not end of session, end of the batch. Okay? So please be interactive. And I feel every time like question is clear with you right now. Yes or no? Okay, so please do work. Please do your homework right now. This is what my string is. We have to generate this output by using this approach, which I have just followed in the toString. Okay, please do your job. I will be waiting. See, hello, am I audible? Everyone? Okay. So see how this approach would be followed if we have three inputs, okay, like A, B, and C. The same thing what we have discussed in the previous scenario, the same thing would be followed in this also, but with some uh, with some precautions, okay, with some additional thing, okay. So suppose let's say if I have my string as ABC, okay, suppose I will have my string as ABC. What I'll do, I'll pass. This is my this is what Priyanshu, Dipanshu, and Ekta. Okay, these three people are there. Priyanshu have this uh, input. Okay, S A B C. What he will do? He will just keep this A with him. Remaining thing he will pass to Dipanshu. Dipanshu will take B with him. Pass C to Ekta. Now Priyanshu will say while passing to Dipanshu like BC, he will say that, hey Dipanshu, please find all permutation of this thing, return to me. Okay, Dipanshu will what? Dipanshu will say, Ekta, please find all permutation of C, return to me. For Ekta again it's that jackpot, right? Ekta will just return what? C. Whatever Dipanshu will have will return from will have from Ekta. He will add his character one time before it, one time after it. Okay, this is what we have just looked upon. Yes or no? Right? Okay. Now these two things will be passed to Priyanshu. Now what Priyanshu will do? Whatever Dipanshu did, C B. Okay. Priyanshu will do what? He will just add A one time before, one time in middle, and one time after. Right? Okay. So if you combine this, all of this, and yeah, here Dipanshu will also have C na from Ekta. Here Priyanshu will also have what? B C, C B, and C from Ekta, from Dipanshu, right? Yes or no? Yes or no? Okay. So from this, this was returned to Priyanshu. But but see, this was returned to Priyanshu. What Priyanshu did? First of all, he added this, right? Next time, what will he do? Next time, what will he do? He have to find a way. He have to find a way so that he can insert everything like this. So that, like, see, for an example, if I have this BC, okay, if I'll consider each and every input. First of all, if I have my BC, right, like BC, so how many possibilities I can have? How many possibilities I can have to insert this A here? Either I can insert my A here, I can insert my A here, right? I can insert my A here, right? These are the only three possibilities. Yes or no? Okay, right? For this BC input. Now, for the input of CB, for the input of CB, let's write it once again, like CB. For CB, how many ways you can insert A? Again, the same thing, right? You know, CB, the same thing. One in the front, one in middle, one in last. So this six thing are what? Nothing but what your answer is. This is what your expectation was. So we did not do anything else. Okay, what we did, wherever you will find a place, insert your character. That is what the solution of this, right? So from this C, we copied that, we inserted B in the last, we passed the solution to Priyanshu. What Priyanshu did? Priyanshu inserted his character every possible way in every input. है ना? ठीक है? This is the solution of this. ठीक है ना? Right? So now if you want to find no the logic of this, or you can say the algorithm for this, you want to think about the algorithm or you want me to implement algorithm? And yeah, one more thing is to that to note here. Whenever we will have no just one character, okay, here here when ekta returns c, okay, whenever we just have one character, we will just have one, sorry, two position to insert. Can I say b can insert in the front and in the last? Yes or no? When we'll have the two characters, such as in this scenario, like in bc and then cb, right? So in every case I can insert in the three place, front, middle and the last, three positions. So can I say that it would be n plus one way I can insert my position? प्लस वन जो भी मैं पास करूंगा कैरेक्टर का प्लस वन होगा, राइट, है ना? So here what is your bigger problem? Your bigger problem is pretty much simple here. So your bigger problem here is what? Like you will be having your string, you will be having your index, okay, and the string would be here what? ABC. You will be starting with 0. This would be a bigger problem. Yes, no? String would be ABC, index would be 0. This would be a bigger problem. Now, what would be your smaller problem? Your smaller problem would be like this: A, B, C, the same string. Index would be increment every time. So this would be your smaller problem. What would be your base case here? See, if we see Ekta, then what she did? She did nothing. She did just return whatever she had to another person. So can I say if we just have one character in the last, you can return that. This will be your base condition. है ना? Yes or no? Yes, that is the same thing. ठीक है? So can you relate with some other problem? And yeah, in the base condition itself, you have to insert some other character, and you have to follow the recursion again and again till the point of time you will not reach the base condition. Okay. So can I say, see, I'll I'll just explain you in detail now. Okay. First of all, we will be having our base condition. Okay. So what is our base case? The base case would be like if our index is equals to our string dot length minus 1, right? If this is following this, then like we'll do what? Let our base result, like base result is equals to empty array. Then after I'll push into my base result. Okay, so br dot push whatever my index element would be, right? So I'll do what? String dot character at, and I'll just pass index here. Okay, and I'll just return br. This is what my base condition. Pretty simple. Yes or no? This is nothing but my base condition, right or not? है ना? ठीक है? Now what will be my second case? Like what will be my recursion? Okay, so here what should be my recursion case? So after this, following your no base condition, your recursion would be what? Let your result is equals to, you have to find the permutations, right? So you have to call the same function permutation, and you have to pass your string and index plus one, your smaller problem, है ना? ठीक है ना? Right? Now this is what my recursion is. Now Now if you observe in your smaller problem, okay, this is what my recursion would be. Now if you observe in your smaller problem, let's say your self work, then I'll initialize it as let my result mr is equals to empty, and I'll just loop it out. I'll just iterate through it. I'll just iterate every result that I can have it. Okay. So let's say I'll do what for let I is equals to 0. I should be less than result dot length, whatever result I got. This is what my self work. Okay. Remember people, I plus plus. And here what I need to do, I'll assign this particular val result of I, whatever my first element in that, I need to assign it to the well, right? And now what my task is, can I say like inside this array the length is 2, so I will have three position to add. Okay, suppose if I have here like bc, so I'll have three positions to add now. Yes or no? Right? Okay. Okay. So can I do this now like this as see after this what I'll do, I'll iterate to something else, like for let j equals to 0, they should be less than well of 0 dot length. How many of you are clear with this? J plus plus. Inside this, you need to find a solution. Now, I'll not write this code inside this. Inside this, you need to find a solution whenever, like, see, this for loop, this inner for loop will run three times, right? This inner for loop will run three times because we are starting from 0 and length is what? 2. So 0 to 2, that is means 3. Can I say that? है ना? So now this logic you have to implement where if your j is equals to 0, if your j is equals to 0, then let's say like whatever my string right now is bc, right? So if my j is equals to 0, then it should insert a here. Okay. If my j is equals to 1, then I need to insert my a here. If my j is equals to 2, I need to insert my a here. ठीक है, this logic you should implement है ना. And I think I wrote every like I wrote entire code है ना. Again I wrote entire code. I was not supposed to, but I wrote it. So this logic I'll keep in your hand. You need to implement it by anyhow, है ना. Take help from ta, take help from the slack team or your teammates also. Anything you have to do, but you have to implement this solution by this. Okay, fine. Can I expect that from everyone? Yes or no? Everyone, I want answer from everyone. Okay, ठीक है. So this should be implemented by your own. I'll not update this. I'll not find any update on this. Okay, so what I'll do now, the next question, can we move to the next question? Can we move to the next question? Okay, okay. So now this question is pretty simple. Now this, like I have two more solution, like if time permits then I will solve one more problem also, but this problem is pretty much clear, like it's very simple. So what the problem says that there is a child, okay, he is running up in a staircase. Okay, there is a child, he is running up in a staircase. Okay, now the condition here is given is like this staircase has n steps. Fine. Okay, now this child can hope can hope one step, two step, and three steps at a time. He can only take one step, two step, three step at a time, cannot take more than three step at a time. Okay, hope steps. Okay, hope steps. Hope means jump, like you can take steps. Okay, now you have to implement a method to count how many possible ways this child can run up the stairs. Okay, so you need to find ways, number of ways to uh, to climb this stair. Okay, to climb this stair. Okay, if I'll take my n is equals to 10, then you need to return me a result. Suppose karo, uh, let's say if I have my n equals to 1. Okay, if I have my n is equals to 1, so can I say that possible number of cases are what? Just one, है ना? We'll just hope one step and he will be there. Okay, so number of, why should I write so long? Now, steps equals to what? 1. Yes or no? है ना? If my n is equals to 2, if my n is equals to 2, then how many possible ways that I can take one step at a time. I can take one step at a time. Either I can take two step at a time. So there will be what? Two ways, है ना? Total number of ways are two. Yes or no? Yes or no, people? Yes, no, right or not? Why you are not energetic today, everyone? Okay, Dipanshu, see, if I have number of steps as two, okay, this is my staircase. I need to go till the second step. Okay, so what this child can do? Either this child can take one step, and either he can take two steps. So there are two ways, na, to reach two. Okay, because see, I told you that this child can hop one step at a time, two step at a time, and three step at a time. Okay, so he took two step at a time, and either he can take one at a time, right? Suppose karo, if I have n equals to 3, then how many ways of he can climb? How many ways he can climb? Either he can take no, 1 plus 1 plus 1, like 1 1 1. Either he can take 2 1. Either he can take 1 2. Either he can take 3. So there are four steps, four ways, right? है ना? ठीक है? Similarly, if you take n equals to 4 na, then you will get answer of 7. If you consider it, like if you calculate it, you will get answer of 7. So this is how, if I pass 3, then I want answer as 4. If I pass 2, then 2. If I pass 4, then 7. This is how I want my program to be implemented. Question is clear? Okay, question is really simple, है ना? So what you have to do here, suppose you have n step, and you can either hope 1 2 and 3 step. So if you hope one step, you will still need to complete n minus 1 step. If you take two step, then you are left with what? N minus 2 steps. If you take three step, you will have n minus 3 steps left. Okay, so since we can hope 1 2 and 3 step at a time, we need to recur for all the three till we reach the nth step. Okay, right? है ना? I hope you understood what I just spoken about. I just spoken about the entire approach, the recursive approach, है ना? Right? So if you need to implement it, your base condition is what? Your base condition would be what? C. Yes, Ekta is right. So Ekta, whenever we will have just one step, so can I say we will just have one step, one way to do, right? If we have zero step, can I say there will be zero way to do, to climb a stair, right? ठीक है? Yes or no? Everyone, है ना? And otherwise, what I need to do? I just need to find step for n minus 3 plus find step for n minus 2 plus find step for n minus 3 until I reach the n. How many of you are clear? People, if you don't respond, I'll not get to know if you are clear or not. I can just see comments from hardly 7 to 10 people. They are regular. What about others? How about others? Please respond, everyone. Okay? Just give me thumbs up. I'll get to know about it. Okay, I can see many yes comment. Okay, that's fine. Okay, similar to coin denomination problem. What is the coin denomination problem? Yeah. Okay. ठीक है. Got it. ठीक है, fine. So let's try to implement it now. Okay. So can we go to the implementation part, or anyone from you still wants me to repeat once again for this? Got it? Everyone got it or not? ठीक है, चलो implementation करते हैं. Okay, Deepak wants one more time. Just a second. Let me share once again. ठीक है, Deepak, what the question here? ठीक है, question says that you will have a one child. He wants to climb a staircase which will be having n step. ठीक है. Now the restriction here, the child is so small that he can just climb one step at a time, two step at a time, or three steps at a time. ठीक है, right? ठीक है. Now suppose if we have n equals to 1. Okay, so you can just, the possible ways how much, like you can will just climb one step, that will be only one way to do it. If we'll be having two step, okay, so how many ways, like you can take 1 plus 1 or 2, there are two ways, है ना? Similarly we have to find for 3 and 4, like for everyone. Okay, this is what we will be implementing by the using recursion. Am I clear, Deepak? Okay, anyone still doesn't get it? Please don't hesitate. You can even ask me for hundredth time as well. Okay, I'm liable to answer you. Okay. So now we will implement a solution for this. And Shivam, there will be one more problem for today. Okay, so please bear with me. Okay. So what we will do here? What we will do here? Will empty out. Yes, Ekta, please ask. What is the question? So our function is find step, and the signature, in the signature what will be passed, we will pass n. Okay, what is our n, we will pass into it. Now if my n is equals to 1, or if my n is equals to 0, I need to return n. This is what my base case is. Yes or no, people? Right or not? है ना? Yes or no? ठीक है, this is what my base case is. When we are at top that n equals 0, even when we have one way to go there, or will no, there will be 0. Ekta, the 0 means what? Wherever you are right now, there is the same. Like suppose karo ki if you are standing at 10th position and you are telling me to go 10th position, so how many steps you will take? 0 na, because you are already in the 10th position. The same way, if my n is 0, then you will get 0. N equals to 1, then you still need to take one step, right? So that's why my n equals to 1 there. Now, now for every other case, what we will do, we will return whatever my summation of find step of n minus 1 plus find step of n minus 2 plus find step of n minus 3. ठीक है, pretty much relatable what we already seen, what we have already seen, right? ठीक है. Okay, Shivam, what we can also use n equals to 0 as one way it will handle three step part. I'm not getting it actually, to be honest. I'm not able to get this. Find step, let me console it out, let me complete the program, then I'll come back to you. Console.log will be printing out find step with 3 first of all. Okay, so let's see what will be our output. This is not able to, too much recursion. Okay, this is what, okay, fine. Let us think about something else. I think so there is something wrong here. There is something wrong here. We need to think about it. uh okay, 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 okay. ठीक है, ठीक है, ठीक है. There is one here, there is a one here, there is a catch, there is one here. Let me print it out. That is still okay. I need to handle one more scenario. Let's try this. I think it should work. Return uh two. Let's try. Yes, this is the case. See what I did. What I did. Anyone got the solution? Anyone got what I just did? Anyone got the got the part what I just did? Hariharan, where were you? I just seen your comment first time for today. So yeah, I'll explain else part for you. No problem. Okay. So Hariharan, you just joined or what? Just tell me so that I'll explain in that particular part. You just joined. No, you know the problem na? Okay. So see what was our problem is. What was our problem is whenever we will be having whenever we will be having suppose करो कि if I want to more if I want to make more simpler to you, then suppose करो कि if you have a zero step, okay, suppose your n equals to 0 or n equals to 1 or n equals to 2 at that particular point of time. If you have seen in the in our diagram also, we have not considered our case for n equals to 0. That was our falsy case. But for n equals to 1, it was 1. For n equals to 2, it was 2, right? So I just take that steps. But for n equals to 0 also it should be 1, because if we will not consider that, it will be go in the minus loops, है ना? That's why we were having the infinite loop questions. Okay. And whenever we will handle this condition and this condition also, it will be working fine, because we have and we have handled everything. So if my question is 0 1 or 2, it will be returned from this, it will be not going backwards. And if I talk about this condition, then it is nothing but my recursive call. So I need to take one step, I need to take two step, I need to take three step. So if I'll take three step, then I'll left with what? N minus 1. If I take two step, then I'll left with what? N minus 2 step and n minus 3 respectively. Yes or no? So that is why I have just called it for recursive call. Okay. So if you just want to do debug of this, let me do the debug. You will get to know about it. Fine. See what my n is right now. My n is 3. Okay. So for n equals 0 and 2, I need not to do anything else. Okay. For a find step n equals to 3 right now, right? So it will be calling what? First of all, it will call what? Find n minus 1. Okay. If you don't understand it, just what? No, divide it for three variables and then sum it. Okay. Because if you don't, it will be not known where the call was happen. है ना? So you will not know with this. Let me take some other value. Let's say if I'll take n equals to 4. Okay. If my n equals 4, 4 minus 1, that is 3. It will call again. Okay. It will call again. Let me do one thing. I think here it is not working somehow. I need to cut it down. Let me go in the Chrome. ठीक है. You can see my screen of Chrome right now. Yes or no? Can you see the screen of Chrome? ठीक है. See, see the carefully here. Whenever we will debug this, it is this. I will take three variables. I will take three variables. Let A is equals to find n minus 1. Let B is equals to minus 2. Let C is equals to n minus 3. Okay. Now just summation of A plus B plus C. Okay. Press the page. I'll run this down. Let's see now what happens. Okay. For n minus 1, that is what? Our n is for 4. So it will be calling for what? 3. Okay. Now it's working now. Okay. Yes or no? So whenever you will have this kind of chain of recursion in one statement, you have to divide it into multiple statements so that you can debug it. Okay. Now again I have to check what is my n right now? 3, right? So for 3 also I'll call again for n equals to 2. Now for n equals to 2 it will return 2, right? Okay, so this part is over. This part is over. है ना? Okay, for this also it will be having the same for n minus 1, that is 4 minus 2, that is 2. It will be returning from this, है ना? Right? For this also, right? And it will finally it will just do what? Return A plus B plus C. That is what? 4. ठीक है? Right? That is why it is printing undefined. Uh, printing undefined. I think so. We are doing something wrong. Return A plus B plus C. It should print whatever we are sending. It's correct. It's undefined. Just a second. Okay, fine. Okay, okay. I got the problem. What's anyone got the problem? What is the problem? Anyone got the problem? Why it is printing undefined? Minor mistake. Okay, I did the semicolon. Let's see. It's not printing yet. What is the problem? Anyone got the problem? Yes or no? I'll say the problem is here. Okay. Now tell me what is the problem? Return outside. No, if I do outside, then it's completely wrong, na? Okay. So what? It should be and be the same line. Okay. Let's do that. Okay. That was the problem. Okay. So if you consider here, whenever you are going, like whenever we are having this, it is considering that we are just returning it, and it is not returning anything, and this is what our it is telling me that it is unreachable code. If you want to see that, let me show you that. Okay, let me show you that in the Mozilla. I think so you can see that. Okay, so let me go in the Mozilla. Can you see my screen of Mozilla? See, right now I am having what? Return, and after I am having this, right? Okay, so if you run this, It will tell you that it is unreachable code after return. That means it is just returning it, and it is, since it is having in the new line, it is returning me nothing. है ना? And this will be not executed because we are returning from here. That is why it is throwing this like warning. But if I just do like this in the same line, I think it should work now. Okay. Okay. Fine. Okay. So I think we are having no time now. So I'll not stretch. If you want me to cover the problem, it is a little problem. It is not like that much of complicated problem. You want me to cover? If you want, then I will cover. If not, if you have some other commitment tomorrow morning, then I will stop it. Anything that you want. Okay, no means we have to no cover, right? We don't have to cover. We can do later. Okay, chalo. Discuss other questions tomorrow. Yeah, okay, fine. Okay. I'll do that. Okay, okay, chalo. So, any particular doubt from for today's class? Okay, Aishwarya, we'll do in the next session. No problem. Any doubt on today's session? Yes or no? So, how was the today's session? You found like you got some confidence with respect to recursion and all. Ekta, I'll say the partial next session only. Then after we will be moving to the algorithmic process. That does mean that we will be covering time complexity, space complexity, and that. Okay. So you will be having that on the next session also. Next session onwards. Okay. I just need to cover up some few questions on the next session that I feel that it is important. Then after we'll be moving to that part. Okay. But I'm talking about how was the today's session. You got the like just what I mean to say about recursion, how it is more simpler. है ना? Many people found it tough because they are not understanding how it is working. That is why. That is the only reason. ठीक है? Fine. चलो. So we will be stop our session today, and yeah, thank you, Nilanjan, Ekta, Joseph. You will not find it many like as we move progress, like as we move further, you will not find it. No, you will not find it that right. Yeah, thank you, Ekta. Logics were cool. I know you will find it more cool things in future. So please do not miss any session. Please try to practice it. I will be uploading every problem, every solution, and note after this session right away. Okay. I have uploaded the previous session, problems and notes also. Fine. ठीक है चलो. So we will meet in the next session. That will be I think so on Friday. And till that time, great. Have a good day and good night. ठीक है. Bye bye.